Transformations of quadratic functions. What do they mean by transformations of a quadratic function? It just means the movement of the parent function. The parent function of a quadratic function would be f of x equaling x squared. Now, you can graph and write different functions that are based off of the parent function. Now, the base format of a quadratic function with the transformations would be f of x equaling a times parentheses x minus h squared plus k. Now, all quadratic functions are going to be based off of that one. So it's always going to be a minus sign. But in order for minus, like x minus your h and k. And so we're going to go through each part of this equation or this formula to describe the transformations of a quadratic function. So the k is on the outside. This is referring to the vertical translation. That means the movement. Are you moving it up or moving it down? So if the k is plus, if it's a positive, so if you have a positive number on the outside at the very end, then that's going up that many units. So if I had plus 4, that means it would go up 4 units. If k is minus a number, a negative number, so if it says minus 4, that means it's going to go down 4. The h is going to be talking about the horizontal translations, sliding it from right and left. So normally in a parent function, the vertex, and this is what they're referring to, the vertex, moving it from left to right. The vertex is at 0, 0. So when in the base format, it's x minus h. So when it's x minus an h squared, it's always going to be moving to the right. So x minus h squared, that means it's going right. Now somebody might say, well, it says a minus a number. Well, keep in mind that minus sign is in the base format. We're only looking at what h is. And if you think about it, if I put a number in for x, so just to say, or in for h, so if I said x minus 4, normally the parent function is at 0. So if I make this equal to 0, where did it go? Or where did it move? So to get x by itself, I add 4 to both sides. And now I have x equals a positive 4. That means it moved 4 to the right. When does it move left? It moves left when h is a negative. So if h was a negative, that would make this minus a negative, let's just say negative 4. X minus a negative number really means x plus 4. So you're going to see it written as x plus 4. When you see inside the parentheses a plus, x plus a number, that is telling you it's going to be moving 4 to the left or moving to the left. And I could do the same thing that I did up here, just make this parentheses equal to 0 and solve for x. I would just have to subtract 4. And subtracting 4 from 0 would give us a negative 4, which means I'm moving to the left of 0 4 steps. So just make sure you know when h is negative, it goes to the left. When h is positive, it goes to the right. Other parts, we have dilations. That is referring to the a, the number in front of the x squared, or the quadratic term. Now we're going to look at a. A is going to determine, is it going vertical or is it going horizontal, the stretching or compressing. So are we doing a vertical stretch vertical compression, horizontal stretch, or horizontal compression. And the location of the A is very important. So for vertical dilations, that means it's going, you're either stretching it or compressing it vertically. If the A is on the outside of the parentheses or there is no parentheses, then it's a vertical dilation. Now, how do you know if it's a vertical stretch or a vertical compression? If the absolute value of A is bigger than 1, for a vertical dilation, if it's bigger than 1, it's going to be a vertical stretch. If A is a fraction between 0 and 1, so the absolute value is between 0 and 1, then it's a vertical compression. Now, if the A is on the inside of the parentheses, such as here, parentheses AX and parentheses squared, you take the absolute value of A, since that's on the inside of the parentheses, think inside the parentheses, it's a horizontal dilation. Now you have to think the opposite of the vertical. So if the absolute value of A is greater than 1 for a horizontal dilation, it would be a compression horizontally. And if it's a fraction between 0 and 1 as a horizontal dilation, then that would be a horizontal stretch because you're stretching it horizontally. That will make a little more sense once you see some examples, but I just wanted to go through a little bit of background before we see some examples. And the last part is a reflection. That is talking about a negative in front of your quadratic term. So the graph of negative f of x, which means the negative is on the outside of the parentheses. That means the last step you're going to be doing is multiplying by a negative number. That means it changes, it affects the y coordinate. That means it goes across the x-axis, because it goes from a positive y value to a negative y value. And if the negative is on the inside of the parentheses, it affects the x-coordinate. And if it affects the x-coordinate, it goes from a positive x value to a negative x value, which means it's going to be reflecting across the y-axis. So let's take a look at some examples. Here we want to just describe the transformation for each quadratic function. So I'm going to look at each number and the location of each number in the equation to determine what kind of transformation I have. So here's my k. My k is a plus 2. Here's my h, and then here's my a. So the k tells us this is translated up 4. So I'm just going to write, or not up 4, up 2. So it goes up 2. The h, since it's a plus 2, it's really x minus a negative 2, which means it's going to the left 2. And then I have the a. The a is my 2. It's on the outside of the parentheses. So that means this is a vertical translation or transformation. And the dilation, so vertical dilation, the absolute value of negative 2 is 2. It's bigger than 1. So this is a vertical stretch. And then there's a negative. The negative is on the outside, so this is a reflection. So it's reflected, and since it's on the outside, it affects the y coordinates. So it's going to be reflected over the x-axis. So that would be the transformation of that function. Example 2. Here my k is here. My h, there is no h in here, so the h is 0. And then here's my a. So that means the k is a negative, so that means it's going down 3. There is no horizontal translation. The a is on the inside, so that means there's a horizontal dilation. So that means it's moving horizontally. So now I got to determine the absolute value of half is half, which is less than 1, but greater than 0. Since it's a horizontal less than 1, it's going to be a horizontal stretch. And then since there's no negative, I don't have a reflection. And our last example, example 3. My k is 4, my h is a positive 1, and then my a is on the outside of the parentheses. So the plus 4 tells us it's going up 4. The 1 tells us this is going to the right 1. The a is on the outside of the parentheses, so this is vertical. And since the absolute value of negative 1/4 is a positive 1/4, it's less than 1 for a vertical dilation, which means it's a vertical compression. And then there's a negative. The negative's on the outside, so it affects the y coordinates. So this would be a reflection over the x-axis. So that is a few examples of how you can describe the transformations of a quadratic function.